So we will see today Elastic Compute Cloud, Amazon's compute group of services. Under compute group of services, there are multiple features provided by Amazon. EC2 is one of them. Lambda is another one for doing compute. Batch processing is there. So many different small features are added on top of it. So let us take a deep dive into Amazon EC2 and see how we can use it in our day-to-day life. So quickly, this is the agenda for the day. We are going to see what is EC2, what are the multiple different types of servers that we are getting, and so the next thing is elasticity. You can start with the smallest server and find that your resources or applications are needing more resources. Then you can go ahead and increase it anytime. It is as good as just a reboot and your system comes up with more resources. So it is elastic in that way. You can start with 1 GB and go all the way to 10 GB, and after the processing is completed, you come back to 1 GB or shut it down also. So it is the entire process of scaling up and down is completely elastic, and it is very easy to start. It hardly takes 5-10 minutes to not even 5-10 minutes, about a minute or two, I would say, to start a server. We have seen it in some of the previous discussions we had. So it is quite simple. Whether you are starting a smallest server or the biggest server, it takes about the same amount of time to bring up a machine. And it is arguably inexpensive, because when the on-premise world, if you want to set up a server with 8 CPU and 16 GB of RAM, you typically order it, procure it, and then get the goods, assemble it, and power it on. And by the time you are up and running, you have spent quite a lot of time and effort in just getting the machine there, and there is cost incurred for that. But here, all you do is go to the dashboard, click on instance, and start. It all completes in about 1 or 2 minutes. So if you compare the entire cost of running and operating all those activities and just starting it, it is inexpensive, and it is secure in a way, because you can use network level security, you can use encryption, you can use VPN, you can use block certain ports. So you can secure your EC2 instances in multiple ways, similar to what you do in on-premise world. And it is reliable also, because all the EC2 instances can be started in multiple availability zone configuration. That is, you will have each instance in different availability and have a load balancer in front of it to have a high availability configuration. And whenever you are using EC2, you can ensure that the capacity has been dedicated to you, so that you can reliably say that I will get 8 GB of RAM and 4 CPUs always for doing your compute operations. So you can buy dedicated hosts, which will as good as those private clusters that you might have in on-premise world. So that is also possible, and you can also have dedicated instances also for extra money. That is, the CPU and the memory that you are getting is dedicated for you, and it is not shared by other people. Another category is on demand. That is, your CPU cycles are shared with other customers, and you will pay a little lower cost for that. So if you want full reliability and the commitment of a CPU and memory, go ahead and buy a dedicated host or dedicated instance. So these are some of the features of EC2. Once we go ahead and see it in the dashboard, how we will see how we can leverage each and every one of them. So we'll just look at some of the fundamental components that make up EC2. We already know what is a region. So here, the EC2 instances are dependent on the geographical area where they are coming from. So you cannot move an EC2 itself from one region to another region. So if your customers are going to be always coming from American region or a Europe region, or based on that geographical area, choose the Amazon region in that continent. So in this case, let us take an example of US. If all of the US customers are in the western part of it, choose an AWS region on the west coast, or if they are in the east, choose the AWS region on the east coast. This way, you can improve your latency and have better customer experience. If you want to have regulatory compliance satisfied also, you can do it based on that. For example, in EU, you cannot do or move data from EU users to outside the EU boundary. So in those cases, you need to start your EC2 instances in the EU region only. So first, the thing is choosing the right region. The next thing that you are concerned about when you're talking about EC2 is availability zones. Almost always use high availability zones, or in other words, use multiple availability zones to ensure that you have an high availability configuration for your application for your clients. And remember that availability zones are designed to be fault tolerant, and all the regions will have a minimum of 2 availability zones. So take advantage of this configuration that is provided to you by default, and set up infrastructure which is highly available for your customers. Even if they say that they don't want multiple availability zones, it is your responsibility to explain them the benefit of having 2 servers running, and then by default it provides you the high availability. You don't have to do anything for having this high availability. So go ahead and recommend that whenever possible. Of course, for test environments and dev environments, you might not require it. For production, it is always good practice to use multiple AZs. So when we are talking about the instance itself, we saw the choice of region, we saw the choice of availability zone. Now we are talking about the instance itself. The instance itself comes in a variety of capacities. And as I said, whether it is a CPU level capacity or a memory level capacity or a network level, so you can choose which one you want. And the time to boot any number of servers, whether you're starting 10 servers or 200 servers or just 1 server, it doesn't matter. When you're starting the server, there will be a top option box which will say how many servers you want. You just mentioned 200, all the 200 servers are going to come up in your account. So the amount of time that you require to start that many clusters are going to be very, very less. And it is absolutely to you as an end customer on how many you want to run. You don't have to worry about will I have the capacity to run this many, or should I need all those things, is the question here. So if your application needs it, go ahead and start it, and you're only going to pay only for what you're using, not for what you might require in future. That is like an on-premise comparison. You need to predict your peak capacity and then design for the peak capacity and then spend money on that as well. Here you're not going to do that. You are going to start as many as you want and then stop them whenever you don't want them. And you get a complete control over all these aspects. The CPU aspect of it, the memory aspect of it, how many you want to run, how long you want to run. As an end user, you will be given complete control over all these aspects. Some of these controls are not possible when you're doing it in the on-premise world. So that's just a feedback or a customer statement from Dow Jones. It is the stock exchange in the United States, and they say that about the productivity or the speed at which they are deploying to production has increased by at least 30% after they moved to Amazon data center. So if somebody says that financial companies are not going to the cloud and production workloads are not running, that is not the case. That is the myth, I would say. This is a publicly available statement, a quotable statement from Dow Jones. You should be able to check that in Google also or in Amazon websites. So never accept anybody saying that financial customers don't go to cloud, or medical insurance companies don't go to cloud. That is all a myth. All of them, all the different customers, sensitive customers, whether it is government or defense, have some kind of workloads running already in the cloud. So when you're looking at instances little bit in depth, I just spoke about this. You get a wide selection of optimized instance types. As you can see here, the instance types are optimized in terms of CPU, memory, and storage and network capacity. So Amazon has predefined some of them into certain terminologies. We will see that what they are. But just remember that they are grouped under CPU optimized machines, memory optimized machines, network optimized machines, and some of them are storage optimized. So that is a combination of a network and I/O capacity. And there are some GPU optimized, that is graphical processing unit optimized for doing image processing or encoding or those kind of activities. And you get a flexible operating systems also. You can use Windows, you can use Linux, you can use Ubuntu, you can use Amazon Linux or any other Linux that can run on the Zen hypervisor systems. So you can bring your own operating system which might be customized, or you can use any one of them which are already available in the cloud market. And there are also pre-packaged softwares also available. Say for example, you want a Drupal content management system, there will be an image available ready for you. You just pay for the cost of it and start using it. And there are some firewalls like F5 and Cisco also have some firewalls available that you can use. So as we were talking about optimized storages, Amazon has categorized instances into multiple varieties as a memory optimized, CPU optimized, storage optimized, network optimized, different categories of families as Amazon calls it. We will see how these families are categorized, what is the how to recognize each family in a short while. But as of now, just remember that there are groups of families based on these broad categories. And on top of that flexibility, you also get flexible operating systems, whether it is Windows, Linux, Red Hat, or Ubuntu, Amazon Linux, or any of the optimized network switches. For example, F5 is a networking company which offers its firewalls as a software as a service model. So you can go ahead and use that image in your customers' accounts. So those kind of packaged softwares are also available, pre-installed, pre-configured. All you have to do is go ahead and start that instance in your account, and you should be ready to go. So apart from these two benefits, there are other benefits like integration with other services. For example, it is integrated with EBS volumes. Attaching or detaching the volumes is very easy. Adding a role or removing a role to perform actions on other services are also easy. And CloudWatch monitoring, you don't have to install any agents on your EC2 instances to start watching the servers. By default, this is integrated, so you should be able to get metrics about the CPU utilization and the network utilization and other metrics like how many bytes have gone, how many bytes have gone in and out, and what is the throttling that is happening there. So there are other services integrated. This is a broad group of services that we need to focus on, and we leverage most of the times to run an EC2 instance. So let us go ahead and see the instance families now. So as you can see here, it starts at the general purpose. That means that when you are talking about a general purpose instance, you can use them for anything. You can use them for a database, a small database, some batch processing, or some kind of a web server or anything. If you don't know what is the best use case and you're starting out in Amazon and you don't know what is your constraint, whether it is a CPU is more or memory is more required, start with the general purpose servers. Under general purpose, you have two categories, T series and the M series. And what a T series means, it is a burstable capacity. Let us say you are given 10 units of or 10 credits of CPU and you are using only 1 credit of CPU. The remaining 9 credits will be stored in your account, and whenever you want 100 credits, if you have a balance of 100 or 99, you will go you will be able to burst to that capacity and utilizing it. If you are not having enough credits, but you will be given only the 10 default credits in your account. So this way your credits keeps on accumulating for every month, and within that month, if you need more capacity, automatically if it is in the credit, it will start using it, and it allows you a burstable capacity whenever you don't use it. When it comes to M4, it has a default performance or consistent performance for the memory and CPU allocated to it, and it is optimized for medium range databases, entry level web servers, and those kind of things. But if you know your application very well and you know that the compute optimized servers are required, then you go ahead and start using a C series machines, that is a C4 or C5 or C3, whichever you want. We will understand in a short while what is the difference between a C4 and a C5. For now, when somebody says that I want a compute optimized instance, you need to think of C series. Likewise, storage and IO optimized ones are called as I3 and D2s. I3 is mainly IO optimized and D2 are disk optimized ones. So likewise, you have memory optimized ones which are called as X1s, and the X1 is the extreme capacity that available as of now in Amazon. It has about terabytes of RAM and 256 CPUs, I think. That is one of the biggest instances that you can as of now launch in Amazon. That is for a single instance. So you can launch multiple instances like that. So think of how much RAM and the CPU capacity that you are getting when you're launching multiple instances. So X2 has been launched, recently launched now. So X1 was until now the only one. Now X2 is there, and you also have R3 and R4, more humble servers. They are not having terabytes of RAM, but we are talking about 256 GB of RAM here. So it's not also small machines. So you get really big machines in Amazon. And finally, there is a GPU or a field programmable array, FPGAs. These are used by people who want to customize how the processes really work, machine learning and artificial intelligence or image processing kind of companies use this kind of CPUs and instances. So you get, these are the broad categories of instance types that are available to you in Amazon. So just to give a quick indication when to use what. So when you're talking about general purpose, as I said, you are talking about the small databases, medium size databases, low traffic websites, web applications. Those kind of things can be under general purpose. If you're talking about compute optimized, mainly it will be used for video encoding and high performance batch processing and those kind of activities. Memory optimized, of course, it will be for databases. We don't have to argue with this scenario here. If you want to have a database with a dedicated performance or a lot of IO is happening, then you definitely need a RAM optimized or memory optimized one. Then you are talking about an R3 series or R series, in other words. So only read write, then the log processing or data warehousing. This is in storage. You are doing some querying. You're talking about terabytes of data being queried and doing some analytics over that. In those cases, you need a storage optimized instance, and I2, I series and D series are your best friends here. Finally, GPU, as I said, machine learning, 3D applications like the goggles that you get nowadays. Every time you are looking in a particular direction, that image is rendered in real time. So for that, you need a really fast processing servers, and the G series are used for that. So this is how the naming convention in Amazon looks like. The slide is slightly disoriented, but anyway, the bottom part is what you need to look at. C4.large, that is how an instance will be named. Whenever we are starting an instance, we will say something T2 micro or C4 large. So what does that mean? So the C series is an instance family, as you can see here, whether it is a compute optimized or RAM optimized. That is what the first character means. The second character means what generation of processors Amazon is using. So when you see a 4, that means that is the fourth generation of processors. And when you say C5, that is the latest generation of processors that you are getting. So this large, after the dot, you have this large and 4x large. What it means is there is a certain set of CPUs allocated for large. And when you say 2x large, you are getting 2 times the size. So the next visual will help you understand what this large, 2x large and 4x large means. So as you can see here, let us say 8x large on the left hand side, extreme left. So that is equivalent to your 4x large. On the background, it might be 4 CPUs. That means that in 8x large, let us say there are 32 CPUs. When you are buying 2 4x large, that means each server will have 16 CPUs. And so if you use 2 of them, which will give the same performance as an 8x large on the left hand side. So likewise, you can go all the way to X large. That means you are getting 2 CPUs here. So if you launch 8 of them, it will be same as launching one 8x large there. So you will get variable flexibility in amount of CPU and memory, and you choose the right combination that you want to use for your clients. So that is how the 8x large, 4x large and 2x large are defined in Amazon. It is just to easy remembrance of how many CPUs you will be getting when somebody says that you will get 8x large. So this is another interesting item when you are talking about EC2 instances. Each and every server will come with a certain hypervisors, certain network information, certain data about what you want to start, what scripts you want to start at boot time, and what is the disk volumes that have been mounted. So once you start this server, you want to access some of this information so that you can use it in your applications. Say you start a server, 2000 servers, you want to collect the IP address of those 2000 servers, especially the public IP addresses. You cannot manually log in or come to the dashboard to collect the public IP addresses of those 2000 servers. There should be some mechanism to pull that information. So for specifically for that reason, Amazon created two tags. One is called instance metadata. So it is the data about your instance. It can be memory, it can be CPU, it can be instance type, or it can be the AMI ID, those kind of things which describe the instance itself. Another field is called instance user data. That is something that you as an end user will pass to that instance. For example, when you are starting a server, you want to run a particular job or a script whenever it is booting. Say for example, disable all USB drives. Whenever the server starts up, you will run this script. So you can install some kind of a package whenever a new server starts. So this kind of information can be passed on to the server at launch time. So this information is called as user data. So you can query both this information from the instance itself using URL, and each URL is particular to that server. So the URL is mentioned here 169.254.169.254. That is a constant URL. And if you launch any server and go ahead and type curl that URL, you will get a field as shown here in the screenshot here. You can do it in a Windows machine using the browser itself, or if you are on a Linux machine, use a curl or a get to get the data. I'll show you when we are going to see the demo how to query this information about instance types and we look at the demo itself. For now, you just know that there is an URL, and using that URL you can query whether it is metadata or user data. So this URL that you see here on your screen right now is for metadata, for instance metadata. The next one is for getting the user data itself. Okay, the next slide it will show you. Okay, yeah. So when you are talking about user data, here I am just giving you an example of how to install HTTPD server while the server boots up itself. So it is a typical shell script. The first one is the bang, shebang it is called. What it means is you are telling the hypervisor of the kernel what kind of script you are going to run. It can be a Perl, it can be Python or anything, but the first line will decide what kind of interpreter is going to be running it with. Here we are saying it's the shell script, and below that we are saying install the HTTPD server, start the HTTPD server and enable it to run on boot. So you can do something similar on Windows also by using PowerShell. So the PowerShell script will look something like this. The first line it says that you're importing the server manager module, and then you're installing it, and then you're starting it. So you can write it in a Linux world, or you can write it in Windows world also. Whichever way you're comfortable, you can pass those parameters to the EC2 instances in runtime. So when you want, how do I retrieve that information? This is how the same URL and the last text, instead of metadata, this part I'm talking about, instead of metadata, you are going to type user data here. That is it. So you use a browser, or as shown here, you use a command prompt and type curl HTTP, this IP address, latest metadata or user data, and it will list you the information from the server itself. And you can do this dynamically also, and you cannot update it, but you can pull that information. It is only a read operation, it is not a write operation. So if you shut down the server, then it will allow you to modify the user data. When it is running, you cannot modify the user data. So the next thing that we are going to see is the life cycle of an EC2 instance. What happens when you start a server, and what are the different stages it goes through before it comes to running. So let us start at the AMI level, that is on the left hand side here. So we are entering here, you are choosing the particular instance with Red Hat Linux or RHEL or Ubuntu or whatever it is, and you're configuring the instance details with CPU, memory and networks. And once you click the launch button, the instance will reach a pending state. That means that it is doing some internal checks, and once everything is sure, it will enter the running state. It will do the hypervisor, it will check whether it's a dedicated instance, whether it is in the right region, whether capacity is there in the availability zone. All those kind of checks will be happening on the background. And once those checks are completed, then the server will reach a running state. So once it reaches the running state, it can choose you can move it into a couple of different states. So let us say you're going to stop the server because you don't want it to be run 24/7 and you just want to stop it for some time. So you click on the stop option. So that is when it goes into a stopping state. While in the stopping state, it will see whether an attached EBS volume is there or an instance store volume is there. If it is an instance store, you cannot do this. All the data will be gone, and you will lose everything that is inside the AMI. So you cannot stop an instance store, you can only terminate it. So that is why it is mentioned it is only EBS backed instances only you can put it into a stopped state. So once you click on that, it will do whether what kind of volume is attached, and it will reach into stopping first, and once all the checks are completed, it will move into a stopped state. And once it is in the stopped state, you can go back and make it running again. When you click on start run, and then you will go to pending and reach back to running. Or if you don't want it, you can terminate that instance. The reason I'm spending time and explaining all these things is you can trigger multiple actions based on these cases. You can use the API call and find out what is the state of my instance, and ask that instance to take some other actions also. Say for example, a stop is triggered, so immediately you can ask your instance to take a EBS snapshot on the background. So immediately, and all the data will be copied from the EBS snapshot and moved into another safe storage, so that you can do additional processing. Or everyday night, there are cases to nowadays that to reduce cost, people shut down their servers at 5 o'clock when they leave, not shut down, stop it 5 o'clock, and then they come back at 9 o'clock and start it. So you immediately trigger a backup at that point of time. So based on this states, the automatic backup will be triggered, and then it will be mounted the next day morning. So that is how you use the different states. So we saw how to move from stopped to terminated. Likewise, when it is running also, you can go ahead and start termination action. Here also, once again, you can trigger a backup whenever a terminate is configured. So that is also possible. And you can also reboot your machine in case if you want to just recycle some services and you want to do a reboot, that is also possible. And some of these actions will happen on the dashboard, and it will be really quick. So if you keep watching the status field, you can see all these states, the pending, running, rebooting, all these states will be available at some point in time in the GUI. So if you pay attention, you should be able to see that. Usually people use a programmatic access to find out the state and trigger some actions based on that. So what we are going to do is quickly going to put some of these behaviors that we just now spoke about, choosing the region, OS, network type, and all those things in a quick demo. So I have already logged into my account, and I am in the Mumbai region today. As you can see here on the right hand side, I am in the Mumbai region. It is highlighted here. The first thing obviously is to launch an instance. So click on launch instance. It will give me the choice of all the different machine images. You see here it is Amazon Linux, Red Hat Linux. If you scroll down, it keeps on going. There are a lot of instances that Amazon itself provides. So if you don't want any of them and you want to look at what other images are available, you can go ahead and click on community AMIs, and it gives you a lot of options here. Let us say I want to run Drupal. All I have to do is just search for Drupal, and you will see here by default Drupal has been installed and configured and available. Bitnami is another company which allows you to run pre-configured images on which makes pre-configured images and makes it available for people to use them. Say if I can find anything related to F5, that is a network company which sells firewalls on the cloud. So there you see here there are F5 is providing some instances here based on these are NAT instances. Okay, that must be there. The idea is you can find a lot of images here, and you should be able to choose whichever you want. Let us search for firewall. You can find here a lot of different firewall images are available. So next thing is marketplace. Here is where you pay some money and get a pre-configured image available. Okay, okay, here you see here Juniper is available. Let me go ahead and click on Juniper, and it gives me the nice little flowchart of what kind of image I want to see. For example, it says I can start a M4 image, and the software cost is this much, and EC2 cost is this much, and I have get a total of this much. So all I have to do is click on continue and keep on going to the next step and start it. automatically I'm paying for the billing part of it, and I'm paying for the instance type, and Amazon will pay the software charges to Juniper automatically. And you see here some of these instances are by default disabled for that AMI. That means that it has been tied to any of this series, that is C series only, compute optimized. So let me just go back. How did I come back here? Let me just go back and start Amazon Linux for our experiments. Remember that you have multiple choices. You can go ahead and choose any of them you want. For playing around, let us stick with Amazon Linux for now and click on select. So here is where you have the multiple instance types and all the generations also. So here, if I want to see only compute optimized ones, I click on this, you will see all the C series here. If I want a memory optimized ones, here I go ahead and click on this, and you'll get the memory optimized ones. So as I said here, you can see here the X1 is having about 1.9 GB of RAM and about 128 CPUs available. So that is how big you have a server that you can launch as on today. There is single server. So likewise, if I put general purpose, you will find all this T2 Nano, which is the smallest one available, about 1 CPU and about zero point 0.5 GB of RAM. And your network performance is also mentioned here. So this is how you choose the different instance types for your servers. And for now, let us stick with T2 Micro. As you can see here, it is the only one that is free tier eligible and guarantees about certain amount of performance. So let us go ahead and click on configure now. So the first field that you see here is the number of instances. If I want more than one instance or 200 instances, all I have to do is just type the number here and Amazon will automatically launch them as necessary. So for now, let us just put a 2 here. And what type of purchasing option? Remember, I told you you have option of choosing on demand or dedicated or reserved instances. We will see some of them in detail. For now, you just know that there are multiple ways of launching your servers, and there are something called spot instances, which allows you to launch instances at a cheaper cost. If it is a bidding war, whoever pays for the most money for unused capacity, Amazon will pay that instance for you. So spot instances are really cheap ones, but there is no guarantee of that instance capacity for you, because if somebody is going to bid more money than you, that instance will be taken from your account and given to the next highest bidder. And spot instances will always have cost lesser than the on-demand instances. That is how the bidding happens. If it is cost is equal to on-demand, people will go ahead and start on-demand itself. So always the bidding war will be there, and if you are worried about cost, you can try that instance and recommend your clients to use that. So there will be an spot instance algorithm, and you need to quote your minimum price and how much you want to persist and where do you want to launch it, all those things. So this is a really advanced, and you can see there is no spot capacity for this instance type. You cannot start spot on T2 Micro. You need to use certain other instances like C series or R series or M series. So that is where you can use spot instances. So that is what this one means. And networks, we will see in depth on what is a VPC, how to define subnets. For now, leave these 3 columns as default itself. But let's ensure that we get a public IP so that we can attach it. We already saw what is an IAM role, whether to attach one or not. So if you want to one, just go ahead and choose it. The next is the shutdown behavior. What happens is if you click on shutdown, do you want to terminate that machine or just stop that machine? You can make sure that you can terminate the machine whenever somebody triggers shutdown. So that is also possible. Big data analysis quite often use this option to ensure that if some server is crashing or some server is finished processing and they are stopped, automatically they will be terminated when you use this option. If you don't want this, then you go ahead and click on this option. Then it will say protect against accidental termination. So there will be additional check that will be made for you, so that you need to enable it and then terminate your instances. So just to make sure that nobody accidentally terminates or reboots your machine or shuts down your machine, you have this checkbox. You just put that check. There will be 2 clicks instead of 1 click to terminate your instance. When you're talking about monitoring, if you enable this, then by default you will be getting a 5-minute monitoring intervals. Every 5 minutes, Amazon will collect the metrics and show it to you. If you want a 1-minute monitoring intervals, then you enable this, and Amazon will give you detailed monitoring for that. So there are additional charges for 1 minute monitoring. For learning purpose, you don't need that kind of detailed monitoring, so ignore that for now. And for production, always recommend this one. For test and dev, you don't need that most of the cases unless there is a problem. Tenancy is what I said about dedicated host and dedicated instances. So when you're saying shared, the CPU and memory is shared with multiple people. When you're saying dedicated, you will get a allocated CPU and nobody will be sharing it with you. When you're saying dedicated host, the entire hardware itself is dedicated for you, and the cost of it also gradually increases from top to bottom. So that is what all these fields mean. So the final field, the important interesting field, advanced details. Here is where you give the user data information. If you want to pass on some information, for example, I want this server to start as a web server. I want to install some web server and some packages by default. So what I'm going to do is I'm just going to copy paste here. What it is going to do is, I don't think so I have a static website here, so I will just remove this line when you're copy pasting. So let us go ahead and just copy this and paste it. The first line, as you can see here, is bin bash. That means that I'm going to run some bash commands and I'm installing a HTTPD server, and I am starting the HTTPD server. I don't think so I have this bucket anymore, so I'm just going to delete this line because I don't have that bucket. So simply we are going to enable a simple HTTP file which will say that where the servers are coming from, and hopefully this command will run here. So if in case anybody is in doubt of what is a tenancy, what it means is this is everything is shared. Here you have a certain boundary of isolation, that is your CPU and memory is allocated to you, and here this is like a private cloud for you. When you say dedicated host, you will get a hypervisor for your own. You will not see that hypervisor, but it will, whenever you start an instance in a particular host, Amazon will ensure that that host is not running any other instances, and the cost for dedicated host is more and dedicated is little less, and when you share it, it is even more lesser. So that is what a tenancy means. Everything shared here, everything less shared, that means the CPU and the memories are dedicated. Here the hardware itself is dedicated for you. That is what a tenancy means. So we saw what is user data. I am sure this should run properly. So let us go ahead and click on add storage. We saw here before, and nothing else to add here, just the defaults. Click on next, add a tags. Yes, I would like to add a tag and call it as Valaxy EC2 demo server 01. Now there are going to be two servers launched. If you notice, I put a number as 2, so let us say server only here. And security group, I want to use a security group which will allow me port 80 and also port 22 so that I can access it. So I'm just going to check which one is having that. And remember, if you are using the default, if you not have already a security group, all you have to do is port 80, and the default is there already. So for experimental purpose, port 22 should be more than enough for you guys to experiment with it, so that you can connect to that instance and try it. Since I'm starting a web server, I'm ensuring port 80 also is there so that we can check it in our browsers. So I have one group already. So let us go ahead and click on review and launch, and Mumbai key is there. So click on launch. So I should be getting 2 instance IDs now. You can see here there are 2 instance IDs for 2 instances. So I'm just going to click on one of them and let us remove it once we go there. Yeah, already looks like one of the servers is already running, and I'm just going to copy this IP address and put it into the chat window here. Now that our both the web servers are running and we are able to access the web servers from the public IP address, and we can see that there is a text which is in white color served from my web server, and you can see the IP addresses of internal IP addresses of those web servers. Let us go ahead and check some of the details that we selected. See, for example, if I choose this instance and go to actions, under action I have instance state as terminate. If I click on terminate, it will not ask me, do you want to terminate? This button is disabled here. That is because we have enabled the termination protection. So first I have to disable that and then come and terminate here. As you can see the text here, this instances will not be terminated. Use change termination protection and then come and do that. So if you really want to do that, there will be an option saying change termination protection, as you can see here. Then click on yes, disable that. And now if I go to instance state terminate, I should be able to terminate this instance successfully. Now if I go ahead and click on that, before that what I want to show you here is you see the instance state is running in this field here. So when I click on terminate, it is going to change now. It is, as you can see here, it is showing us shutting down, and in a short while it will be terminated. So the instance state will constantly, this is the life cycle that we saw some time back. So from running, we initiated a terminate option, then it is shutting down, and obviously it is going down. So you can see here already all the resources have been removed. For example, the public IP address, the DNS name, and all those things have been removed from one of our servers. So once your instance terminates, all the resources that are associated with it will be released slowly one by one, and Amazon will do the background checks and release it from your account. So let us go to the one that is already running. So you see here all these values and parameters are still there, and all the items or parameters that are necessary are shown in this one screen itself. So some of the important ones is like termination protection is true here, and whether monitoring is basic or advanced or detailed monitoring is there. What is the AMI ID of the machine that you are running, and what are the security groups, what is the availability zone, what is the instance type. Almost all the details that you want most needed most of the times is listed in this description page. When you go to status checks, there are two types of status checks. One is called system status checks, another one is called as instance status checks. So there are two checks. That is why in the top you will see here status checks 2 of 2 is passed. What that means is the first one is Amazon will do the hardware level checks on its own. It will do the hypervisor, CPU, memory, and all those things. So that is called as a system status checks. And when it is the instance status checks, it will check whether the instance itself is running, whether any application monitoring, and whether the anything above the hardware level that Amazon cannot measure, it will show up here. So that is what this one means, instance status checks. Only when these two are successful, Amazon will give you a 2 of 2 checks passed. So if I can bring your attention back to the instance state, you can see here this is terminated already, and the state has changed into a different color. So that is what status check means, and you can create an alarm so that your monitoring team will get a notification whenever something goes wrong. So if you click on this one, we will see in detail when you're looking at monitoring later. So for now, if you click on this, automatically the instance ID and the status checks, everything will be pre-configured, and you should be able to set up and monitoring quickly by using this button here. So moving on, the next field, monitoring. This is an interesting part. It will show you all the CPU utilization, memory, and all those not memory, CPU and network utilization parameters. Amazon never shows the memory part by default. If you want the memory parameters, you need to configure some scripts to pick up that information. If it is Linux, you can run Topaz or a top command, or not Topaz, a top command, and find out what is the memory utilization and show it in your dashboard. You can also use some of the third-party tools, but whichever is convenient for you. Since this instance is just now started, we are not seeing any metrics as of now here. So it will start getting populated slowly. Let me see if I can choose it anything. The minimum data that I have is the last hour, so it will take some time for the data to start showing up here. So that is what the monitoring field is all about. The tags is what we created just now, the name Valaxy EC2 demo server. So next thing, select that instance, go to instance settings. Let me remove this part now, and if I go here and choose view or change user data, it will give me the user data that I have passed on to that server. So we can go and check it on the console also, or in the GUI also. See here, to edit your instance data, you need to first stop your instance. That is, in other words, you cannot dynamically change these values. You need to stop them first to change them. And you can also change your instance type also. For example, if you want to change it from T2 micro to T2 nano, or make it into M4 large, what you need to do is you just need to stop them and then come back to this option that is change instance type, and you should be able to change that. So that is how these are all the fields. And if you want to have some kind of a logs, what is happening at the background, well, boot time. And if you want to look at that behavior, you have to click on this option which says get system log, and it will give you a snapshot of what happened during boot time. If you ran some scripts and if you were feeling that it didn't run properly, this is how you come and troubleshoot and see what happened in the background. You remember we installed HTTPD, and you can see here it has picked up the values from my boot scripts and it installed HTTPD. And if I can really find it out, it will run the other command also where it will set it at start. So this is how you troubleshoot boot time scripts, whether it is running or not. Of course, you can go log into the server and check up some of the D messages, but this is another way where you can get it from the console itself. So what else is here? So I'm just going to log into the server and try to pull the user data and metadata. Just going to create another session, new session, SSH, go to that. So when you're talking about user data and where it can be used, quite often application teams will use that for pre-installing, pre-configuring some scripts, and infrastructure teams will also use it for creating some user IDs or installing some default packages. Something called as MOTD is there, message of the day. So like this, we are getting a welcome message, right? Sometimes people use it for saying you have logged into production, or you are logged into test servers and things like that. So it depends upon how you want to use it. Both application teams and infrastructure teams use the user data field. Sometimes people install Chef client or some kind of client applications so that it can talk to the master and pull the latest configurations. So if I remember the URL correctly, it is going to be http://254.169.254/latest/metadata. Okay, then I might have made a mistake here. I'm just going to see whether this will work. Nope. I'm just going to get the IP address from the pack itself so that we know exactly. HTTP 169.254.254. I will not be able to copy this. So I got the correct URL now. Let me just go ahead and paste it. So you can see here, when you're querying for metadata, you have a lot of all these options. So whether what is the AMI ID, what is the instance type, and what is my public IP address. So what I need to do that to query them is just go ahead and choose. Let us say first, let us get the instance type, for instance. Okay, that is funny. So here you can see here T2 micro, immediately it prompts up. So if I want to get my public IP address, that is going to be under networks. So under network, I should be able to have two options, and it says me interfaces. So let me type interfaces, and okay, this keeps on going. It is asking me what is the MAC address. Okay, I made an error. Did I make an error? Okay, not that one. Let me get a public IP4. I'm sorry guys, I just got the wrong one. What we should have done here is /latest/meta-data/public IP4. So here, oh my god, I made a mistake again. there is a duplicate here. Obviously it is not working. Okay, so in case you are not able to notice it clearly, I'm just going to run it again. So it gives you, when you run curl metadata / it gives you all these options, and if you want a public IP address, all you have to do is curl metadata, and public IP4 will be there. Let me not miss it again. Yeah, public IP4, press enter, and it gives me the IP address 13.127 blah blah blah. So this is how you get your instance metadata. If you want the user data itself, all you have to change this is user data to metadata to user data, and I think it is one word. Let me just try it. No, it is a hyphenated word. Yeah, let me just clear my screen so that we can clearly see when you're pulling the metadata. So curl, same IP address, latest user hyphen data, and it gives me the bin bash command that we ran there, and it gives me the text that with the command saying pages served from hostname hyphen f. This is a Linux command, so if you give it in backticks in runtime, this will be executed and the value will be substituted here. So think of it as a small script that has been here. So whenever you run it on every server, dynamically it will pick up the IP address of that server and show the pages with that server. So when you're troubleshooting it, you will know which server the pages are coming from and easily go ahead to that server and fix it. So that is how EC2 is, the basic components as we saw. We saw how to create an instance, we saw how to protect it from accidental damage, and we saw how to monitor it and what availability zone it is running and what roles it can be running. If you want to create an image of this server, all you have to do is go ahead, click on actions, and you have this option saying image, and then click on create image. It will ask you some information like what is the name of the image, where you want to store it. So let's go ahead and say test web server by Valaxy. So I'm just going to give the name to my description also. Whether do you want to reboot the server while you're taking the snapshot? Yes, I'm going to say yes, so that there is not data corruption when you're doing it. So all I'm going to do is click on create image now. So you see here pending image, that means that it is going to take it in the background. So click on close, and on the left hand side you will see this option when you're doing EBS volumes. We saw here EBS volumes and snapshots, and above that you have AMIs. So we are going to look at that option which says images under that AMIs. So if I go ahead and click on that, you can see here my test web server by Valaxy is getting built and the status is pending. So it is doing the background processing, it is copying the data, and it is getting it ready. And meanwhile, if I want to share it to the world, all I have to do it is just go ahead and click on edit and click on public. That means that everybody in the world should be able to access it. I mean, it is still pending, so it is refusing to do that, but once it is successful, we should be able to do that. You can see here modifying failed because the AMI ID is currently pending and may not be used for this operation. So anyway, let it wait for it to get completed. It just takes about a few minutes for the image to get created. So now that my image has been created, it is available for reuse. What I'm going to do is I'm just going to make it into a public access. So I'm just going to click on public and click on save. And if anybody in the world wants to use my image, they can go ahead and start using it. It should reflect here shortly. It takes some time for propagating it because it needs to copy it and do the changes and all those kind of things. So it will take some time to propagate. You can see here this image is currently public. Okay, great. So in case if I want to start a server based on this image, let us say some client has shared me this image and it is showing to me in my AMIs. So I want to start a server based on that. All I have to do is select on that image and click on launch. Wait a second, it is doing some processing. Let it be in available state. Then we should be able to launch based on that. So now we are launching an server from my test a web server image. So by default, a web server should be running, and the IP address of this image will be what it will be. Let me ask that question to all of you. What do you think will be the IP address here? As you can see on the screen, the IP address is going to be the old one from where the image was taken, because the script is going to, the user data script is going to run only once at boot time and not every time. So this file was created by the server when it ran once, and that file gets copied to all the AMIs. So if you want to rerun it, stop the instance, update the user data field again, and reboot it, it will start, and then you'll create a new image with a new file. So that is how you update it. So that is how you take an image and start a server from that image.